Good morning, students. So far we are learning lesson 4, electric charge and electric current. So what is the unit of electric charge? What is the unit of electric charge? Coulomb is the unit of electric charge. What is the unit of electric current? Ampere is the unit of electric current. So we have learned formula. What is the formula? Q equal to Ne. Charge formula Q equal to Ne. Electric current formula I equal to Q divided by T. So another one formula Q equal to I into T. So then resistance also we have learned. What is the formula? What is the denote the letter resistance? Or what's the formula for resistance? V by I. So resistance means or V potential difference, I electric current. What is the unit of resistance? Ohm is the unit of resistance. What is the unit of potential difference? Volt is the unit of potential difference. What is the unit of electric current? Ampere is the unit of electric current. So this formula, unit and denote the letter. So everything you should study thoroughly. So last class I remembered this everything, and today also I told the formula and unit and denote the letter. So I'm thinking all the students know all the denote the letters, unit and formula. And then today we are going to learn about how to draw a electric circuit. For that, different components we are using for electric circuit diagram and to draw means more components we are using now. So how we are using the components we can see. First one, listen all of you. First one, electric cell. So already you have know the positive terminal and the negative terminal. So this we will say as cell. So what is this? Cell. The cell consists of a positive terminal and negative terminal. Now the combination of cells are called, what is that? Combination of cells are called battery. So this battery. So first cell and combination of cells are called battery. The next one, switch. So switch very important, all of you know. So switch or key. You can write a key. Okay. Switch or key. So first cell and the positive terminal, negative terminal. Then combination of battery. Next one not a key. Now coil of wire. See the coil of wire. These are the components, coil of wire. So first one cell, battery, key, and what is this? Coil of wire. Now electric bulb. See electric bulb. So what is this? Electric bulb. And last class we have learned about resistance. No, resistance we can draw like this also. Otherwise the resistance. What is this? Resistance. The next one, variable resistance or rheostat. You can draw like this or that. Variable resistance or rheostat. So I am writing variable resistance. So what is this? Resistance. Like this also you can draw, or this symbol also we can draw, resistance and variable resistance or rheostat. What is this? Variable resistance or rheostat we can say. The next one, ammeter. Ammeter already we have learned. What is the use of ammeter? What is the use of ammeter? To measure electric current. Now voltmeter. What is the use of voltmeter? To measure the potential difference. What is the use of voltmeter? What is that? To measure the potential difference. Ammeter to measure the electric current. The next transformer. Two coils are there, primary coil and secondary coil. This transformer. So here some symbols we have learned. By using this symbol we can draw the circuit diagram. First one, cell, important components, cell and key, then connecting wire. So wire, this components, by using the connecting wire only we can connect, and the electric bulb, the resistance. So these are the important components. So you all know, I'm thinking you all know the symbols, the cell symbol and battery, combination of cells, then key, then coil of wire, electric bulb, resistance, variable resistance, ammeter, voltmeter, transformer. Then also more symbols are there. See the book and you have to learn. Next, we can see by using these symbols how to draw the circuit diagram. Now, what is this symbol called? Anybody know? Key. Key or switch. So, what is this? Resistance. Now, what is this? Cell. Right. Now, listen. Here, the circuit diagram. The current passes from positive terminal to negative terminal. So, from here to here, the current passes through. Now here important four components are there: battery, then key or switch, then resistance, and connecting wire. This wire, the positive terminal of the battery connected through key, and the resistance, and the other end of the resistance connected to the negative terminal of the battery. So by using this connecting wire, we can connect the electrical component. Understand? Like this, you have to draw the circuit diagram. Now in this circuit, series, two types are there. One is series circuit, another one is the parallel circuit. So first one series and parallel. So give some example for series connection. Do you know? Serial and series connection. Parallel, in our home, the connections, everything parallel connection. So by using these components, we can draw the circuit diagram. First, series connection. We can draw series connection. Now, what is the symbol called? Electric bulb. Two electric bulbs are connected in series. Two electric bulbs are connected in series. This battery, then switch key. Now the current passes from positive terminal to negative terminal. Two bulbs are there. These two are connected in series. Suppose in our main supply 230 volt. 30 volt current supply is there. So here the current passes through this direction. Current denoted the letter I. See here series connection, so the current is same, but which one different means potential difference different. Okay, current same. Why means we are getting 230 from the main, we are getting 230 volt. So here two bulbs are connected in series, so two bulbs also share and the current passes through. So each bulb you will get to 115 volt. Each bulb will get. Okay. So this total current share, how many bulbs are there? Share and each bulb share and get the volt. Okay. Suppose here 12 bulbs are connected in serial light. 12 bulbs are connected in series. Suppose here 230 or 220 volt is there. So divided by 12. How many bulbs we are using? Total amount of current, total current divided by how many bulbs we are using. That you should divide, means you will get how much volt you are using. Okay. Suppose 240 volt, 230 volt, each how much volt main supply is there. From the main, how many volt is there? How much bulb we are using, share and we can take in the series circuit. Okay. Now parallel circuit, listen the difference. Parallel circuit, the bulbs are connected in parallel. listen, here different loop. See, here one loop, like that different loops are there in the parallel circuit. These two bulbs are in parallel. These two electric bulbs are in series. Do you know the difference? Series connection and parallel connection. Parallel connection here for this I1, for this I2. But here only I is the current is the same, but here current different, potential difference same. Suppose here 230 volt is each bulb you will get 230. So like this parallel connection only in our home. All the homes parallel connection only given. So each bulb and each fan will get 230 volt. Okay. But the series connection means how many bulb we are using, total current share and they will take in series connection. But in parallel connection, separate the bulb, each bulb has 230 volt. Here all the bulb join and 230 volt. Parallel connection, each bulb will get 230 volt. Okay. Can you understand the series connection and parallel connection? Now we have drawn, we have learned about circuit diagram and how to draw circuit diagram and two connections, series connection and parallel connection. How we can draw series connection, how we can draw parallel connection. You know the difference between series connection and parallel connection. Then next we can learn about heating effect of electric current. Heating effect of electric current. So in our home we are using so many electric things we are using. No? So for that, suppose example fan we are using. For what purpose we are using fan? We will get air. That artificial air or natural air, artificial air we are getting. No? So after half an hour, if you touch that fan, what happened? There heat is there. No? So there we are using electric appliances for useful purpose we are using. No? So there electric current, electrical energy, we are getting electrical energy. So half portion our purpose we are using and half portion is dissipated as heat. Okay, all the electrical appliances like that, mixie, then fridge, everything like that, really heat also there. In some electrical appliances, electric energy is converted into only for heat. So give some example for heating effect of electric current. Iron box. All of you know this, iron box. So iron box, then electric heater. Electric heater. So this electric iron box, electric heater, electric toaster, this devices, everything only used for heating effect only we are using. Iron box we are using. Suppose it is not giving heat. What purpose we are using? No, we won't use. No. So like that here electric heater also only for heating only we are using. So the some electrical appliances we are using only for heat and some electrical appliances give what purpose we are using, that useful also will get half energy is dissipated as heat energy. Okay, this is the heating effect of electric current. Heating effect of electric current just converted electrical energy into heat energy. That only Joule's laws of heating. Electrical energy into heat energy. This heating effect of electric current. Give some example for heating effect of electric current. One question is there. What's the answer? Iron box, electric heater. What's the answer? Iron box, electric heater. Any two device only they asked. So we can write iron box and electric heater. And one more electric toaster also there. That two only asked. So these two answer you have to write. Book back and question is there. Give some examples for heating effect of electric current. Any two device only they asked. So what's the answer? Iron box and electric heater. Okay. So heating effect of electric current means electrical energy, just conversion of electrical energy into heat energy. The example for heating effect of electric current, iron box and electric heater. Okay. Can you understand? Now, two types of current we are using. No, what are the two types? Do you know? Direct current and alternating current. Direct current. Direct current we can say DC. Alternating current. Alternating current, that we can say AC. Yes. Okay. DC current and AC current. AC means alternating current. DC means direct current. So this direct current, well, the main purpose by which device we are using is battery. By using the battery only we are getting current in this direct current. Okay, direct current, by using battery we are getting the electrons transfer from negative terminal to positive terminal. Okay, direct current, the electrons passes from which terminal? Negative terminal to positive terminal. So we are saying this direct current is called unidirectional current. Okay, direct current is called unidirectional current. So graph we can draw like this for direct current. Straight line graph you get here time, here current. Okay, so we will get the graph for direct current, straight line graph we will get. So the direct current, which one we are using? By using the battery only we are getting current in direct current. We are using battery, we are getting current. The electrons transfer from negative terminal to positive terminal. So the direct current is called unidirectional current. The graph we can draw as a straight line. Okay. Then we can see alternating current. Alternating current, AC current. So our home supply everything AC current. Okay. So for that AC current, the current passes from positive terminal to negative terminal. So that graph, the current passes alternatively. See this alternative. This graph all of you know. Alternatively it will pass on thrust and trough. Alternatively this way will pass. Okay. Now here frequency. Frequency means what? Number of vibration per second. Per second how many vibration? Like this vibration is there. No. Number of vibration per second is called, what is that? Frequency. What is the unit of frequency? Hertz is the unit of frequency. So number of vibration per second is called frequency, and wavelength also we can measure one rotation. Here this one rotation, wavelength we can measure, and the maximum displacement is called what? Amplitude. Maximum displacement of this wave is called amplitude. So this is the maximum displacement amplitude. This thrust and trough only one vibration. Okay. So the number of vibration per second only, what is that? Frequency. So this direct current graph, straight line, and alternating current graph, alternatively it passes through. So their frequency is the number of vibration per second is called frequency. Here also time and current. The graph drawn the time and current. So see the difference between these two graphs, this direct current graph and this AC current graph. So two types of current is there, direct current and alternating current. So direct current name is the unidirectional current. So then which one we are using here? Battery. So negative, the current electrons passes from negative terminal to positive terminal. But here alternating current, AC current, our home supply everything, alternating current. So here number of vibration per second, alternate, the current passes through alternatively is called alternating current. Okay. Now just convert into DC into AC means what is the rectifier. By using the rectifier only we can convert DC into AC. Okay, the conversion of DC into AC is called what? Rectifying current. Then magnetic effect of current. Suppose conductor, we are using this conductor. Conductor means what? Ones who conduct electricity. Suppose here this conductor, the current passes this direction. Current passes this fully. The conductor means ones who conduct electricity only conductor. The electric current passes through this direction. The magnetic field produced in perpendicular direction, perpendicular to the flow of current. Okay, the magnetic field produced in the conductor perpendicular to the magnetic field. The magnetic field produced to the conductor perpendicular to the flow of electric current. So this is called magnetic effect of electric current. So so far we have learned how to draw the electric circuit, what are the components are there to draw electric circuit, and what are the four main components. What are the four main components? Battery, then connecting wire, then what? Then switch. So these are the main components. No. So then heating effect of electric current. The example for heating effect of electric current, what are they? Iron box and electric heater. Then magnetic effect of conductor. magnetic effect of electric current, JK conductor. Conductor means what? Ones who conduct electricity, conductor. The magnetic field is perpendicular to the flow of current is called magnetic effect of electric current. There are two types of current, direct current and alternating current. Direct current we can say as DC, alternating current we can say as DC. And just to see the two graph, direct current graph and alternating current graph. So far we have learned, then we can mark the question. Take a look. Room letter 6, sixth question. Name any two appliances which work under the principle of heating effect of current. The answer you have to write there itself near the question. Electric heater, iron box. Electric heater, iron box. Question, name two appliances which work under the principle of heating effect of current. What's the answer? Electric heater, iron box. The next question, seventh question. How are the home appliances connected? General, in series and parallel. Give reason. Just write it. Home appliances are connected in parallel arrangement so that each of them can be put on on and off off independently, which is essential in household. Using the first small one, potential difference across each appliances will be same. And second point, if the appliances are connected in series, the potential difference across each appliances will vary depending on the resistance of the appliances. That's all. Filling the blanks. First one, electrons move from higher potential to lower potential. Higher, lower. Then second one, the direction opposite to the movement of electrons is called conventional current. Third one, the EMF of a cell is analogous to pumping to a pipeline. Pumping. The domestic electricity in India is an AC with a frequency of 50 Hz. Today I have marked room letter 6, sixth question and seventh question. Already I have given assignment, and today 2 questions, sixth question and seventh question you have to learn and write as the assignment note. Thank you.